Okay, let's look at the practice exam 3, problem number 3. Alright, so we're going to use this substitution to first rewrite this differential equation. Alright, so let's do that. Alright, so here I'm going to just solve for x so that it's easier to plug in. So you have x is equal to t minus 2. Alright. So this differential equation becomes, right, so you have 4 times, right, x squared, but x squared is t minus 2 quantity squared, so I'm going to go ahead and multiply out. So t squared minus 4t plus 4. Right, then you have a 16x, so 16 times t minus 2, so plus 16t minus 16 times 2, so 32. Then you have plus 17, so plus 17. Alright, then y double prime, this is a derivative with respect to x, but we can switch it to derivative of y with respect to t. Right, then minus 8y, 8y is 8y, so 8y, and the right hand side is still 0. Right, then since we're using this substitution, so plugging in x equals negative 2 is equivalent to, right, so if you look at y as a function of t, then x equals negative 2 corresponds to x negative 2 plus 2, so it's a plug-in 0. So this is y of t equal to 0 equals 1, right? And here y prime of negative 2 is equivalent to plugging in 0, so that's equal to 0, right? So let's clean it up a little bit. So you can see that this is going to give you, right, so let's see, 4t squared, right, so this is going to be 4 times negative 4t, so negative 16t, oh actually I forgot t here, sorry. So this guy, negative 16t, and there's a positive 16t, they cancel out. Then you have 4 times 4 is 16, minus 32 is negative 16, plus 17 is positive 1. So positive 1 here. So then you have a y squared, second derivative of y with respect to t, and a minus 8y is equal to 0. So this is the new equation in terms of t. Then let's do the power series. So this is going to be 4t squared plus 1 times, so this is second derivative, so you have a summation, n goes from 2 to infinity. Then you have n minus 1 cn, but you have a t to the n minus 2, right? Then you have a minus 8, then y is summation, n goes from 0 to infinity, cn t to the n. So this is equal to 0. Alright, so let's multiply out. So 4t squared times that, it's going to give you, right, so we have a summation, still goes from n equals 2 to infinity, and you have a 4, and I'm going to just go ahead and multiply this out. So you have a n squared minus n, and a cn, then you have a t to the nth power, so that's that, and 1 times that, so it's going to be plus summation n goes from 2 to infinity. You have a n times n minus 1 times Cn times t to the n minus 2. Alright, then minus, I'm going to just put the 8 inside, so it's a summation. N goes from 0 to infinity, 8Cn t to the n. This is equal to 0. Alright, so we're going to have to do a little bit of adjusting. So I want to have t to the n for everyone. So I have to change that. So you have currently n minus 2. So increase that by 2. So I'm going to decrease the starting number by 2. Then we can switch that to n plus 2 times n plus 1 and a Cn plus 2 and a t to the n. So by reducing the starting number by 2, we can increase these indices by 2. Right, so you have a t to the n there. We already have t to the n there. We don't have to do anything. And the only thing we have to do is here. We want to start from 0, but we can just start from 0 because when n equals to 0, this term is 0. N equals 1, the term is also 0. So we can simply change that to 0. Alright, then we can just put them all together in one summation. So you have a summation. N goes from 0 to infinity. Alright, so let's collect the terms. So you have, let's see, Cn, so it's going to have 4n squared minus 4n. Alright, and other Cn is minus 8. Cn. Then you have plus n plus 2, n plus 1, Cn plus 2. Then you have a t to the n. This is equal to 0. Alright, then we know that since the right hand side is 0, we have to make sure that each coefficient is equal to 0. So we're going to set this guy equal to 0. And we can actually factor this guy out. So pull 4 out. And you have n squared minus n minus 2. So we can factor that out. N minus 2. And then you have n plus 1. Alright. So we have that. Then we have, we're going to set this equal to 0. So for Cn plus 2, so we're going to get Cn plus 2 is equal to, let's see, negative 4 n minus 2 times n plus 1 over quantity n plus 1, n plus 2, and you have a n plus 1. Alright, then actually Cn. Right, so we can actually cancel out n plus 1 here and n plus 1 there. Then you can get this negative 4 times n minus 2 over n plus 2 Cn. Alright. Then first thing we want to do is, let's see, since we know that y of 0 is equal to 1, which means that, so we know that the y of 0 equals 1, which tells you that C0 is going to be equal to 1. Right? So let's look at the even coefficients. Right? So C0 is 1. Alright, so in order to get C2, we can use this formula. So n equals 0. So C2 is equal to, All right, so n equals 0, so it's going to be at 0, so it's a negative 2, and so it's a negative 4 times negative 2 over 2. So it's going to be, let's see, what's that? Let's see, 4 and the 2 divided by 2, so it's negative 4. Actually, it was positive 4, isn't it? Negative, sorry. Positive 4. So all I did was just to plug in 0 here, because we want to get C2. So n equals 0. So plug in 0. Negative 2 times negative 4 is 8 divided by 2. So positive 4. Right? Once you get positive 4, then you have a C4 is going to be, so if you want to get 4, so n equals 2, but if n is 2, this is actually 0. So once you get 0. Alright, once C4 is 0, all the other even terms is going to be 0. So C6 is 0, and a C8 is 0, and so on. Right? And odd terms, if you want to look at the odd terms, then you look at the y prime of 0 is actually 0 from here. This tells you that the C1 is actually 0. But once C1 is 0, then we know that the next one, C3, is 0, and the C5 is 0, and the C7 is 0. And so on, right? So all the odd terms are 0, right? So remember that you have a power series. Y is equal to C0 plus C1t plus C2t squared plus C3t cubed, and so on, right? And we know that all the odd terms are 0, so which means that this is 0, right? And this is 0, right? 0, right? Then we know that the C1 is 1, so this is equal to 1, right? C2 is equal to 4, right? So we know that this is going to be simply 1 plus 4 times t squared, which is going to be equal to 1 plus 4 times, let's see, t is x plus 2 squared, right? That's how they found the solution of the initial value problem. All right, that's it. I hope that this was clear.